In this question, we have to determine the value of current for time greater than or equal to 1 second. Now, initially the switch is at A, which means we have to consider this particular loop of the circuit, and the rest we should not consider. This is open. Okay. Now, in the circuit we have a DC voltage source in series with a resistor and a capacitor. In such case, the expression for voltage across the capacitor is Vc is equal to 20 into 1 minus e power minus t. Now at time t is equal to 1 second, okay, Vc will be equal to 12.64 volts. Okay, now we will consider the second case where this particular circuit, okay, is only considered and this circuit is not considered. We have a open here. Okay, now we have a capacitor, a resistor and an inductor in series. So this is a series RLC circuit, but here there is an initial voltage across this capacitor, and that voltage is equal to the voltage across the capacitor at the end of the first second. Okay, now in this case the circuit will be like this. It's a capacitor, then we have a resistor, then we have an inductor. Okay, this is the resistor, inductor, and there will be a voltage across this capacitor, which at time t equal to 1 is 12.64 volts. Okay, now since this is a series RLC circuit, I will first find the poles of the circuit. Is equal to minus alpha plus or minus root of alpha square minus omega naught square, where for a series RLC circuit alpha is equal to R by 2L, so that will be equal to 0.5. Now similarly omega naught is equal to 1 by root LC, so that is equal to 1. So S will be equal to minus 0.5 plus or minus J 0.866. Okay, hence my current expression will be e power minus 0.5 t a cos 0.866 t plus b sin 0.866 t. Now the value of a and b can be determined by making use of the initial conditions. So one initial condition that we know is the current in the circuit at time t equal to 0. Okay, now this current t equal to 0 means actually at the first second. Okay, now I of 0 is equal to 0. That is because the value of current can only increase exponentially. Okay, that is because of the presence of a inductor. The current cannot take up a sudden instantaneous value. Okay, now we need one more initial condition, because we have two constants here. We need two conditions in order to determine the value of a and b. Now the initial voltage across the inductor, okay, will be equal to the initial value of voltage across the capacitor. The reason being, there won't be any voltage across the resistor because of the absence of current. So this is equal to 12.64. now L di by dt is equal to, at time t equal to 0 is equal to 12.64. so applying these two conditions, we will get I of t is equal to 3.65 e power minus 0.5 t sin 0.866 t. So this is the expression for current after time t greater than 1.